So this is my Arduino and Pure Data project. The idea behind it is that the distance sensors measure where the player is in the room when they have it attached to them, so they can hold it, it can be soldered to a hat or a part of a body part, and as they move around the room while playing a game or potentially even in VR, the sound will move with them towards speakers in each corner of the room. So it'd be on a 5.1 or 7.1 setup. At the moment it's built for a 5.1 in the program Pure Data, which procedurally generates all the sounds from the soundscape. We have a soundscape that is made for like a forest, kind of like a Skyrim-y theme, which is what I was going for anyway, all procedurally made using Pure Data. The patch is available to download from the bottom of this page, and I hope you enjoy it. I'm about to go through how I made it, and then we'll do a video of it in action. We have my Arduino sketch alongside my Pure Data patch just here. So what we're going to do is go straight to the Arduino sketch. So all we've got to do is define our pins that we're using on the Arduino board here, declare distance, the sensors and everything else we need, and then we're going to move straight on to the setup. So here we have our setup for our what the Arduino reads first. So it would be first off defining the serial port and opening that, and that's in the BPS. That's opening and declaring the BPS. So that's going to be what Pure Data reads when the Arduino is plugged in. Next, we're going to just pop it into a loop so it constantly reads the distance from each trigger pins, each of the pins on the distance sensors, and then they go straight into the Arduino. Now, what we need to do is, so this next bit is vital in connecting them both. So it's already reading the BPS from opening the serial port up here, but then we need to write what the distance sensors are reading. So from the left and right sensor, whatever you want to call them, they're technically X and Y, but I just called them left and right just to make it easier to define them, because when I first set this up, they were just sitting next to each other. So as each reads here, as they write each sensor, so each of the numbers that they're inputting, then they just pop them straight into PD. So you can see they're moving because the Arduino is currently on at the moment and it's reading these numbers, and that's exactly what they're reading. So you can see X is having a bit of a panic moment and jumping around a bit, but yes, this is how they're reading it. And same, so the rest of it just declares the distance and how it's going to be reading it and everything like that. And it was also, I put a delay on it as well, because otherwise it will just be beep 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 in numbers left, right and centre, and it needs a bit of a, but that's why they jump a little bit more, so that you see X having a bit of a mare, but because there's something in front of it and it can't quite figure out where it's going. But that's how the sketch works. So if we head on over to the patch just here, so what you've had to do is use the COM port object in PD, and what that does is it opens itself up to receive data from the Arduino. So, and it's also using 9600 baud rate, which is what we've declared here within serial begin. This just opens it and closes it, and this declares the device as the Arduino here. Now what I've had to do is, I was trying to do this in vanilla at first, but I could not get more than one sensor coming out of COM port. What I found is repack is a really useful object, and it enables me to take all the numbers that are coming from the COM port object, i.e. from the Arduino, and unpack them into two different number boxes here, and that's what I've done. So if I head straight onto my XY graph here, now it may look a bit like a spider web, however I assure you that it was a little bit more complicated than that. So what we've done here is we've got our inlets here with both of our numbers coming in. We've got X and our Y from our graph, and what we needed to do is take the numbers that are coming in from X and Y and convert them into volume for each speaker. So you can see by the maths, a little bit of maths just here, that we've managed to do that, and so the first step was to take it and divide it by the length of the room. So the room that we're working at the moment is about 4.5 meters, and we've already defined centimeters to be used in our sketch. So we just moved them over and we've divided it by 450. Then what we've had to do is we've got to use an expression to reverse that number to enable it to come out. Rather than it going from high volume to low, we need to go from low to high, so we've had to reverse that. And then we've divided by 2 because then we're obviously adding both of these inlets, both X, Y, together to then create a different volume for each speaker as the Arduino moves around the room. So here we have the maths for this, and feel free to check them out. My patch is, and the sketch I have uploaded as well. So feel free to download them and check them out and play around, because it's some pretty interesting stuff. So what we're gonna do now is just get rid of the XY part here, and then we're gonna concentrate on what the sounds are. So first sound would be, this is going to be coming out of our front left speaker, and so as we move closer to it, it will make more of a sound. It's going to be wind, so it's got quite a complicated wind patch in here. We've got a couple of patches added together just to create some more wind. On our back left speaker, we have a good fire patch, which takes different aspects here of Andy Farnell's theory on fire in his book Designing Sound, and adds them together to create kind of a quite an ambient fire patch, but also it can be, depending on how close I am to the speaker, it can get quite violent, as in trying to make it so it seems like you're standing next to a fire. For our back right, we have the sea, so we've got some pretty intense waves coming right next to it, using some pretty cool patches that just randomize each way the wave's going to be setting in. Finally, from front right, we've got our insect, which is pretty, he's a good little fella, and when you are on the other side of the room, you generally can't hear him. It's one of those things where you've got to be close to a cricket to be able to hear them. So I tried to implement that in there. We've got a couple of patches that we didn't end up using in the end, like rustling and stuff like that. We just kind of, and like a panning as well. It just sounded better with less in it, to be honest, because there's only so much you can hear in a forest. But yeah, so I'm just going to show you guys what it's like in action now. So here I am, and this is it all up on a big screen. So at the moment we can see the numbers having a bit of a freak out because they're kind of being interrupted, their signal's being a bit interrupted by a lot of the stuff that's around. But I'm about to go put it on my head and give a walk around the room. While I do that, you're going to be able to hear a little bit of variation in the sound from the speakers. It might not be able to be fantastic from the video, however I do encourage you, if you want to download the patch from the webpage that you're viewing this on, or from my portfolio website, whether you're viewing it on YouTube or whatever. We'll be able to have a bit of a play around, and especially if you've got surround sound, you'll be able to see the patch move. Yeah, enjoy. So here we are in the forest. So it should be a bit clearer now, as it can just read the sensors around the walls. Be careful with this wire. So now what should be happening is the fire sound is getting a lot quieter, which it is, and I should be hearing a lot of insect, which is also happening. So now as I get a little bit closer to the waves in the speaker just here, I can hear the fire sound then getting louder, and same with the waves. Now I'm going to disappear out the frame for a little bit and go for a walk up to the fire. Which has happened as well. Then I'm going to go back just a little bit, back into a frame, and finally go to where the wind's blowing in. Again, good. You can hear kind of the movement, and as we're moving, and so this is my Arduino Pure Data patch. I hope you've enjoyed. It's going to get a bit funny now. Put it down. Hope you've enjoyed it. And please do download it, and please email me if you have any more questions. Thank you.